The topic is computing partial derivatives algebraically. So let's do the first example. Let f of xy equal e to the sine of x over y. And question A, find partial derivative with respect to x of xy. Again, definition says to find partial derivative with respect to x, we regard y as a constant and differentiate f of xy with respect to x. So, but again, we need to differentiate e to the u. So we have to look at the formula or for the derivative of e to a function, and it's equal using the it's just going to be u prime e to the u using the chain rule. That's what I want to say. All right, so fx of xy will be equal, like I said, I'm using this, so it will be partial, my u happens to be all that stuff, so partial with respect of x of sine of x over y, and all this times e to the u. Right? Now, all I need is to find a partial of a sine of a u. So think of it again, we need to use this formula. Again, there's a chain rule, so it's going to be u prime. This means derivative of the inside times the cosine of the inside. So my u this time happens to be x over u. So partial, so this will be equal partial with respect to x of x over y cosine of u is x over y, times, let me do this separately, times e to the sine of x over y. Now all I need is partial with respect to x of x over y, and I'm done. And of course here I need, maybe I should write it, I need a quotient rule. F over g prime is equal f prime g minus g prime f over g squared. So that's going to give me partial with respect to x of x times a y minus partial with respect to x. Well, actually we could have taken 1 over y outside, but I already wrote it, so let me do it the long way. Partial with respect of x of y, times x over y squared, and then times cosine of x over y e sine of x over y. Right? Now this is going to be just a 0 because y is a constant. So all we need is partial with respect to x of x, which is 1. 1 times y is y. So the numerator would be y over y squared cosine of x over y e sine of x over y. And this is just going to be equal, y over y is 1 over y. So 1 over y cosine of x over y e sine of x over y. And that, by the way, we could have done this partial derivative. Since we know 1 over y is a constant, we could have just write 1 over y partial, see how quick, partial with respect to x of x, which is 1 over y times 1, which is that. So that should be done, that would be much faster. Alright, now let's do the b. The b is, we need to do same way. We're supposed to use e to the u prime, which is u prime e to the u. So that would be partial with respect to y of sine of x over y right times e to the sine of x over y. Right? Now this is equal to, again this is a u, so partial with respect to y of x over y. Now I'm using this formula, cosine of x over y, and then e sine of x over y, which is equal, now here the x is a constant, so I can take the x outside, right? And then partial with respect to y. 1 over y is just y negative 1, right? Now cosine of x over y, e sine of x over y. Now this is going to be x times minus, I'm just going to put it here, y, minus 1 is negative 2, cosine of x over y, e sine of x over y, and then we're done. You could move this to the denominator and just rewrite it as minus x over y squared, cosine of x over y, e sine of x over y. And this will be the answer. Alright, let's do the next example. Let f of x equal ln of x plus square root of x squared plus y squared. And let's find partial of f with respect to x. So partial of f with respect to x is equal, again I'm using this definition, ln of u prime is u prime over u. So this whole thing is my u. So partial with respect to x of all the inside, I'm going to rewrite it as x plus square root x squared plus y squared over x plus square root of x squared plus y squared squared. Not squared, just that, right? It's a u prime over u. Alright, now how do we do this? I'm going to rewrite the square root as, so I can use the power rule. This will be equal partial with respect to x of x is 1 plus partial with respect to x of x squared plus y squared 1/2. Now everything over x plus square root of x squared plus y squared. Oops, not squared. Now using power rule, this is going to be 1 plus 1/2 x squared plus y squared. 1/2 minus 1 is negative 1/2 times partial with respect to x of the inside, means this, u prime. And then you want everything to be over x plus square root x squared plus y squared. Now this is going to be equal 1 plus let me make sure I do the parentheses here. So it'll be 1 plus 1/2. I'm just gonna, instead of using, I'm gonna do this 1 over 2. I'm gonna move x squared plus y squared negative 1/2 to the denominator. It becomes 1/2, which is square root. So square root of x squared plus y squared times partial with respect to x of 2 of x squared is 2x. So it's 2x plus 0. So 2x, 1 times 2x. And then you want all that over x plus square root x squared plus y squared. Can we simplify this a little bit? Yes. This is going to be, I'm just going to divide by this number. This is going to be 1 over x plus square root of x squared plus y squared plus 2x over, so I'm just going to move this to the denominator. So that would be 2 square root times square root. Square root times square root is just x squared plus y squared. So I did this. Square root of something times square root of something is just the u. That's the formula I used. And that's it. So let's do partial with respect to y. This is going to be equal, same way, partial with respect to y of a u. Again, I'm using this definition of x plus x squared plus y squared 1/2 over x plus square root of x squared plus y squared over u, right? Now, partial with respect to y of x is just 0, so I don't have to write it. And then I'm going to use power rule here, using this formula. This will be 1/2 x squared plus y squared. 1/2 minus 1 is negative 1/2 times partial with respect to y of x squared plus y squared. Now everything over x plus square root of x squared plus y squared. Now this is going to be equal to 1/2 x squared plus y squared negative 1/2. Partial with respect to y of 2y is 2y plus 0, so that's just a 2y over x plus square root x squared plus y squared. This 2 goes with this 2. Now you will have y over x squared plus y squared to 1/2. I'm just going to write square root, right, and then over x plus square root of x squared plus y squared. Now again, all I need to do is just move this to the denominator. In other words, we're dividing. So this will be equal y over, just dividing fraction by number. So that will be square root x squared plus y squared times x plus square root of x squared plus y squared. And we're done. Let me just check this, make sure I didn't make a mistake. I think I made a mistake here. This is x plus. So when I multiply this by that, I knew it. It should be equal to, let me write it. How can I write this down easy? So this will be 2 square root of that times x plus square root of x squared plus y squared. So forget about, we didn't use this property. I didn't see the x and didn't notice this x. And then can we simplify the 2? Here we can, because it's a product, so this 2 can go and that's it. So the answer will be all that from here to here. And that's it for this example.